Okay, today's lesson is finding the shape or finding the area of irregular figures. So shapes that aren't necessarily a parallelogram, triangle, or trapezoid. And the way that we'll do that is we will use shapes that we know, we'll divide those irregular figures into those shapes, and then we'll find the area that way. And this is more commonly what you will end up with. The area problems that you will see generally are more difficult than just finding the area of the trapezoid. Okay, so here's how I recommend that you do this. If it is not a worksheet, and in the homework that I'm going to give you will be a worksheet, so you won't have to draw it. But when we used to do this out of the textbook, I would have them draw the pictures for themselves so that they could then show lines to show how you divide the shape. Sometimes the shapes will have lines in them, like there's a line here and there's a line here. Sometimes you want to divide on those lines, sometimes not. So we look at this shape, and this shape is not any known shape. It's a five-sided shape, and it's not any of those four or three-sided shapes that we know. It's not a pentagon, so we really have to divide it into two. So I'm going to draw my line here, because that divides this shape into two shapes that I know. The shape on the left, we have a triangle. The shape on the right, we have what? Parallelogram. Yeah, I think I heard a trapezoid in there. It can't be a trapezoid because trapezoids have exactly one pair of parallel lines. They can't have two. So parallelogram has two sets of parallel lines, the vertical lines and the more diagonal lines there. All right, so we're going to write in any new measurements. For our parallelogram, we have a base of 3, a height of 2, so there's nothing to write in there. For our triangle, we have a base of 3. What is the height of this triangle? 3. Good. So you might want to write that in. So the first thing I'm going to do is find the area of the triangle. So I'm going to do area, and I'm going to put a little T there so that I know what I'm finding the area of. The area of the triangle is 1/2 the base times the height. So that's half of 9, which is 4.5 square meters. Now I'm going to find the area of the parallelogram. So that parallelogram, I'm going to do area and put a little P beside it so that I know I'm finding the area of the parallelogram, is just base times height. So that's 3 times 2. So the area of the parallelogram is 6 square meters. What would the area of the whole thing be? Grace?
10.5 square meters.
Good, 10.5. We just add the two areas together. So we take the area of the triangle plus the area of the parallelogram, and that gives us the area overall. So 6, actually I should put the 4.5 there. 4.5 plus 6 equals 10.5 square meters. Okay, any questions about that? Okay, let's take a look at another one. All right, does anyone want to come up and show me where you would divide this? Come on up, Irene. Here. Yeah, it works to divide it on the dotted line. It won't always. What shapes did you divide it into, Irene? What do we have on the left?
Trapezoid and a triangle.
Okay, trapezoid and triangles. We're not going to be able to use T this time because we have two different things, trapezoid and triangle. So let's take a look at our trapezoid. For our trapezoid, we need 1/2 base 1 plus base 2 times the height. So we have one of the bases is 4. We have the other base, which is 6. Do we know the height of that trapezoid? Because we need to know that also.
Yes.
Okay, Jake, what's the height of that trapezoid?
I don't, would it be 5 times 6 divided by...
No, I don't want to know any formula. All I want to know is what's H for this trapezoid. We know that base 1 is 4, base 2 is 6, so the height is going to be this segment right here. Do we know what that height is? Pat?
It would be 4 because it shows a arrow down.
Good, good. So this 6 is telling us that this segment from here to here is 6 centimeters. We know that the whole thing is 10 centimeters, so that means there are 4 centimeters left for that little segment right there. Okay, so let's start with the area of the trapezoid, and I'm going to have to write out more than just a t, so I'm going to do area of the trapezoid is 1/2 base 1 plus base 2 times the height. When you are looking for the bases on a trapezoid, the bases are always the 2 lines that are parallel to each other. So in this trapezoid, our bases are the 2 parallel lines. The height is always perpendicular or forms a T with the bases. You always want to look for that T when you're talking about height. Okay, so 4 plus 6 is 10. Half of 10 is 5. 5 times 4 is 20. So the area of our trapezoid is 20 square centimeters. Now I'm going to find the area of the triangle. It's 1/2. The base of our triangle is 6. The height is also 6. Again, the base and the height need to form a T with each other. So that's how we know to use these 2 segments. So 1/2, 6 times, yeah, it makes an L or a T. It makes that perpendicular crossing there. Okay, so half of 6 times 6. 6 times 6 is 36. Half of that is 18. So the area of the triangle is 18 square centimeters. Adding the 2 together, we have 20 plus 18 equals 38 square centimeters. Any questions about that one? Okay, I want you guys to try the next one. And if you want to go ahead and work on the following one, you can do that as well. At both ways. 2 ways you can divide it. Who divided it vertically? Raise your hand if you divided it vertically. All right. Eli, Eve. Okay, so you divided it this way? Okay, so if you divided it that way, you've got this triangle over here. The base of that triangle is 16. The height is 12. So the area of triangle 1, I was going to say area 1, would equal 1/2 the base times the height, which would be 96. The area of triangle 2 would be 1/2. Its base is also 16. Its height is 8, so 1/2 16 times 8, which is 64. When you add 96 plus 64, you get 160 square feet. Now, if you divided it horizontally, if you got using a different color, you would have divided it here. In that case, the area of the first triangle, the triangle on top, this has a base of, actually, can you do it that way? Ailey did it that way. You did it this way, right? And it worked. But I don't think, you don't, she got lucky and it worked, but we're assuming that this segment and this segment were both 8. Isn't that what you assumed? Yeah. That's not always going to be true. It did work in this case, but there's nothing that shows us exactly how those are divided. So we don't actually know that they're both 8. Yeah, so it's better to do it using known measurements. So it does work out that way. So I take back what I said about doing it 2 ways. I wouldn't recommend doing it that way. Okay, Jake?
Well, they both have 3 dotted lines for the height.
Right, but the dotted lines, that doesn't tell us anything. It's not actually showing us measurement. It's just showing us a potential way to divide. All right, let's look ahead at the next one. The next one's a lot more complex. How do you want to divide this? Does anyone want to come up and do it? Elena, come on up and divide it. Okay, good. I know that this way works because this is the way I divided it as well. So now we end up with 3 shapes. So we have this shape. which is a rectangle. We use the formula for parallelogram, so let me find the area of that shape. And I'm going to color code. You might need to write area of rectangle or area of parallelogram. The area of the red shape is just 3 times 6, which is 18 square meters. Then we have another rectangle. We have this rectangle. We know the length of this rectangle, it's 6, but what is the height of this rectangle? Ross.
1 meter.
1 meter. Good. How did you know that?
That's on 3 meters there on the left.
Okay.
There was a little cycle of 2 meters and also a little bit left over. I think that was just 1 meter.
Good. Okay, so he's looking over here. This segment is 3 meters, and this little segment is 2 meters. So if we take 2 away from 3, we're left with 1. So this is 1 meter. So to find the area of the blue rectangle, we do 6 times 1, which is 6 square meters. And then the last one, we have a triangle. We need to know the base and the height in order to compute the area of the triangle. What is the base of this triangle? Let's use this bottom segment as the base. Elena?
4 because the height or the length of the other 2 rectangles is 6.
Okay, so we had 6 across here, we had 6 across here. Taking that away from 16 gives us 4. And then what's the height of that triangle? Brayden? 3. Good. Going back to, we can look over here at the height of the rectangle. So the area of the triangle is 1/2 the base times the height. 4 times 3 is 12. Half of that is 6. So the area of the triangle is 6 square meters. So when we add those all up to the neutral color, we have 18 plus 6 plus 6 equals 30 square meters. Okay, the last problem on our slide. Does anyone still need to copy this? Last problem, we'll read it together. Derek and Susan want to stain their deck, shown below. A gallon-sized can of deck stain costs $36.98. 1 can of stain will cover 250 square feet. How many cans of stain should they buy? How much will it cost? How much deck stain will be left? This is the type of question you might get as an open-ended PSSA type question. There's more than one question that you have to answer, so make sure you answer them all. Before we get started, I want to talk about how we're going to divide this shape, because there's one error that people very commonly make, and I just want to head that off before you even get started. So volunteer to come up and divide it. Adria, come on up.
You have to get these terms.
Okay, Adria, what's the shape on the left?
Square. Or like a rectangle.
Yeah, it's a rectangle. Kind of looks like a square
Yeah,
on my
on
board.
here, but on
What is the shape on the right?
I called it a trapezoid.
It is a trapezoid, yes. A lot of times people look at it and think it's a triangle. It's not a triangle unless you take it all the way over here. And if you did that, then you would have to make,
You have to make that.
you would have to do something really strange with this, and we don't have enough measurements. So you have to make sure you count this as a trapezoid, not as a triangle. Irene?
Could you also make another cut to make it a triangle and a square? Or a rectangle, I mean?
Meaning cutting across.
Like cutting it, like
Something that you-
here. Because that's what I did. I'm not quite done yet. Like it looks a little lower.
See. Well, if you did that, though, you have no way of knowing.
The only problem is we don't have.
Yeah, you do. 9. Because of
Okay,
this.
yes, you would, yes, you would.
Because
I think you
then this
could-
is 3. Okay. Because the way I did it, it worked
I'm
out.
gonna take that off for right now. All right, so go to it on this problem. I'll give you some time to work on it, and then we'll talk about it. Okay, Violet. Yes, let's talk about how, first tell me your answer. Let's make sure you're correct before you demonstrate. Okay, good. The total area of this figure is 270 square feet. All right, now, do you want to tell us how you got it?
Instead of doing a trapezoid, I did a rectangle, another rectangle, and a trapezoid.
Okay, so Violet used this, right? Did I do it right? Okay, she used Irene's method. We always end up with Irene's method. All right, Violet. So the area of the first rectangle, we'll say area of rectangle 1 was what?
180.
Okay, so 12 times 15. Guys, don't talk, please. Gives us 180 square feet. Okay, let's do the area of the second rectangle. What was the base of the second rectangle? What's that? 12, okay, 12. And what was its height? 3. Okay, so taking 12 times 3, you got what?
36.
Good, 36 square feet. And then the area of the triangle. What did you use as the base of the triangle? 12. And what did you use as its height? 9. Okay, so 12 and 9. So 1/2. 12 times 9 gave you what? 54 square feet. And those added together give us the total area of 270 square feet. How many of you got 270 square feet? Okay, there's enough people who did not get it. Those of you who did not get it, did you use the trapezoid method?
Yeah.
Let's talk about what the area of the trapezoid would be for those of you who did it that way. So I'm going to erase this dividing line. So you should still have gotten the same area for the rectangle that she got. So the area of the rectangle should have been 180 square feet. With the trapezoid, you want to consider the bases are the two parallel segments. So this and this are the two bases. So the area of the trapezoid is 1/2 base 1, which is 12. Base 2 would be 3, because it's telling us that this segment is 9, so there are 3 left over. So you would have 12 plus 3. And then the height of the trapezoid would be this segment that forms a T or an L with those sections perpendicular. We know that it was 15 on this side of the rectangle, so from here to here was 15, so there would be 12 left over. So we would use 12 as the height. 12 plus 3 is 15, so we have half of 15. I'm actually going to do this different. I'm going to do half of 12 is 6, and then 6 times 15 would be 90. So you get that the area of the trapezoid is 90 square feet. Adding those together gives you 270 square feet. Are we all okay with this now? Okay. Now, how many cans of stain should they buy? Devin? 2. They should buy 2 cans of stain. How much will it cost? So 2 cans. How much will it cost to buy 2 cans of stain? Ailey? Good, $73. Now, if you were doing this, if this were a PSSA question, you would need to be writing these out, but I'm out of space. I don't have more paper to write on, so I'm just going to insert them up there. And how much deck stain will be left? Devin?
117.76.
Yeah. Which I'm going to round to 118, so I'm going to say there will be 118 ounces left. How many of you got that?
I had the first two.
All right, and we got it.
I had the other where I said that enough to cover 100.
Enough. Okay, so you got how much square feet could be covered, and I didn't do it that way, so I'm assuming that's right. I saw a lot of people with that. Devin, can you explain how you got that?
Okay.
I love the way Devin was thinking. He said to me, "How do you do that thing where if there's like dogs to cats?" So he was automatically, his brain went to proportions on this.
I divided 128 into 250.
Okay.
I got 0.5 to 1, 2.
Okay, so you did 250 divided by 128. and you got, or wait, no, you did it the other way, I'm sorry. Which way did you do it?
I did 128 divided by.
128 divided by, okay. 128 divided by 250 and got what?
0.512.
0.512. And what does that 0.512 represent?
How many ounces per foot?
Per square foot.
Yeah.
Yeah, make sure you specify that. So it's 0.512 ounces for every square foot. So to cover 1 square foot, you have to use 0.512 ounces. And then what did you do?
I divided 230 because that's how many feet were left.
Okay.
How many square feet were left.
Mm-hmm.
And I got, yeah, and then I got 117.76.
Okay, so you took the two, tell me what you had again?
The 230
The
divided.
230, okay, so there were 230 square feet left in the can, and you divided that by 0.5, you divided it by 0.512 or multiplied it by 0.512?
I divided it. I think.
No, I don't think so, because 230 divided by 0.512, you multiply. 230 times 0.512 gives you the amount, which is 118. Now, I actually used a proportion when I did it. If you used a proportion, here's what I did. I said that 250 feet, square feet, you can cover 250 square feet with 128 ounces, and so then I put 270 square feet over X, figured out that X was 138, and subtracted that from the 256. I could have also done what you did with the 230, would work better. Okay? All right, that was a good real life kind of problem that you would actually have to solve. I thought of this problem because I used to have a somewhat irregularly shaped deck, and I had to go through this kind of a process when figuring out how much stain to buy for my deck.
I found another way to cut it.
Another way?
Yeah.
How? Yeah, come on up and show me.
Well, I still need that.
Oh, you still need that. Wait, you got to.
No, like the beginning.
Like there. Because you'll have the 3.
You'd have
And
the
the
3 for
12.
that triangle, but then we know the height of this triangle.
Yeah, 12.
Oh, yeah, it would still be 12. Yeah, all right. Yeah, you could do it that way. All right. A little more of a complicated way, but yeah, absolutely.
I was sitting here thinking about like,